And today in this lecture, I'm going to talk about Git, and this is required for the first marked group work. And I'll explain. So this is what I'll explain. So I will explain what is version control. Essentially, Git is one of the ways to do version control. And then GitHub, which is a website which allows you to store your version control database, essentially. And then finally, GitHub Pages, which allows you to host a website or your code online where the code is actually stored in a GitHub repository. Okay, I'll start with kind of background in terms of what is version control. And so essentially, it's a system that allows you to make changes to one file, or actually more than one file over time. And then so you can go back to any previous versions later if you want to. Okay, and this is actually mostly used for software code files, HTML, CSS, JavaScript, but it can also be, say, Python or C or just Java. And usually it works best with the files, which is essentially text-based. And you could do version control, for example, to PDF files or image files, or even video or audio files, still possible. But then the version control software usually cannot understand these files as they can in text-based files, like a JavaScript HTML files. So all you can do is just save a new version. It will not be able to tell, for example, what has been changed between this version and the last version. Okay, there's many different ways you can do version control. And you can do this locally. And for example, and you have a file and you have different versions of this file. And both the latest version of the file and all the previous version is stored on your own computer. So that's the local version control. And many of you are probably doing this already. For example, and when you're writing a final report, you might create a Word document and you make a copy and name it version 0.1. And then later on, you create a new copy and name it version 0.2, and so on and so forth. So this is a collection of different versions of your document. Okay, and so this is probably easy. You don't really need any particular software or tools to do that. But also, it can have potential problems. For example, you might make changes, unintended changes to a wrong file, then you lose your previous history or you lose your changes. And also it becomes a bit more unwieldy. For example, you have 20 different versions of the same files, and it's quite difficult to know which version is what, which is the version you're looking for, has the changes you're looking for. Yeah, and also this approach does not scale and with large number of files. And so if a single Word document may be still okay, but for example, if you're writing code, even just for a simple Vue.js app, you might have, say, HTML files and CSS files, JavaScript files, maybe some image files as well. And if you want to keep the versioning, keep track of the versioning of each of these individual files, it becomes much harder to do that manually. Okay, an improved version or more complicated, advanced, depends on what you think, is a centralized version control system. So how it works is you have this version control system which runs on a server that each individual computer would have access to. So this is mostly for the shared access to the version history of the document, and which can be useful when you say have a team working on the same code or same document. So you still have this version database, stores different versions of the same file, and then each user can access this version database from their computer. So that's to address the issues is a local version control system and does not support remote collaboration. So you have a team, you have the code and the changes on your computer, other people cannot see it. Okay, and so this is why this system is created. Okay, and so the kind of popular version, or was popular maybe 5 or even 10 years ago, was system or even longer, and such as CBS or Subversion. And I'm not sure even anyone of you would have heard that. I don't think there's that many people use them anymore. Okay. Okay, and then so for each people who have access to the version control system, and if they need to make changes to a particular file, they need to check out that file. So usually these are, say, people check out the file, it says, okay, I'm going to make changes to this particular file. Then other people are not allowed to make changes to that particular file or version at the same time. And because then they have problems with two people making different changes to the same file, it's going to be difficult to merge the errors and merge the changes later. But also, and that becomes the issue, that means only one people can work on a file at the same time, which can be annoying, especially say it's a file that people are just working on different parts of the file, but they still can't do it. Okay, and then there's the final version or the final variant of the version control system is called the distributed version control system. And so this is what it looks like. So in this system, and you still have a server which hosts a versioning this database and containing all the versions. And the difference is that for each people that have access to the database, they maintain their own local database as well. So they have a copy of the central database, and they can make changes to any of the files in this database. And so don't have to worry about if any other people are doing the change on the same file. So what they do is if they make a new version or changes, that changes will go to their local version database first. And then that changes will be uploaded or pushed, which is a term used in Git, and to the central version database. And in the case, two people making different changes to the same file, and then the person made the change later would have to merge, is responsible for merging the changes from two people. Okay, and we're going to cover only the basics, but not these. In this module, we're going to only cover the basic usage scenario, mostly just you and sending your changes to the server, and you might decide to use that in the team environment, but we will not cover things like, say, how do you merge changes from two people making different changes to the same file. Okay, and so the Git is one example of distributed version control systems. I think almost all the projects using Git now, and there's very few people still using CBS or Subversion, and because this obvious advantages, for example, and you don't have to wait people to finish and change a file before you can make changes to it. Yeah, okay, so another advantage of this distributed version control system is, because everyone has a copy of the all the entire history, and even if something happened to the server, you still have the copy that you can restore. And maybe you don't have all the latest changes, but you should have most of the history, or to save most of the work. In theory, and if all the versions are fully and in sync, then they will always be the same, and then you will not lose anything. And if the server or some user lose their data or files. Okay, the next part is about the 3 states of the Git. As I mentioned before, and Git is one of the examples of the so-called distributed version systems. And it has these 3 states, which can be a little bit confusing. But hopefully there's tools to make it a bit easier. And also, as the more you use it, and the more you will get used to these different concepts or states. And also that's kind of necessary just because of the, how do I say, the features, and these are required to enable a distributed version control system. Okay, and so they have these, each file will have these 3 states, and modified, staged, and committed. So modified is probably the most staged, how do I say? And straightforward just means you make changes to the file. So you already saved the version of the file, and you have new changes made to the file, which hasn't been saved yet. That just means modified. And the staged means, so you marked a file or with changes to go to the next commit, or essentially the next version of your document or file. And so you have the changes to your files, and you can make changes to, say, 10 files. But for the next version of your project, which contains many files, you don't want to include in all 10 change the files. Maybe you only want to include 3 of these changes to change the files in the next version of your data and of your version control system, which is completely fine. And if the files are marked to be included in the next version of your system or project, and they will be called staged. So not all the modified files will be staged. Usually that is the case for just what if it's just one simple project. Okay, and finally the state is called committed. That means you created a new version of your code or your project, and that's being saved in your local versioning database. If you remember, each people would have a copy of the entire history locally. So if you save the changes as a new version in your local version system or version database, then you have the changes committed. That's the change. And so again, just to recap you first, make changes to your file. This is, you do regardless whether the version control or not, you will make changes to your code. And it does not say the version control does not automatically including all the changes in the next version. You need to tell the version control what changes you want to include in the new version or the next version. And once these changes are saved, then it's called committed. Okay, and the next part I'm going to talk about in terms of the 3 sections or 3 places that related to saving these files. Okay, and so the one is called the working tree or working directory, and the other one is called the staging area, and finally it's called the Git repository. And so the working directory or the working tree is where your code is. For example, you're creating a new view project, and then you have a directory with HTML, CSS, JavaScript, and maybe some image files as well. And that folder is your working directory or working tree. So you already have that. Okay, and so the staging area is a reference to the change that will be included in the next version. And we mentioned it before, you have this staged files, means the files that are being marked for next version. So these files goes to this staging area. And yeah. And finally, the Git directory or Git repository is where you actually save the new version. Well, actually, it has the information about all the versions you saved in the database. That's essentially the versioning database containing all the versions. Okay, and so the working directory is just your code folder, and staging area is just conceptually including all the changes you want to include in the next version. And then there's this .git directory. So actually later on you will see, and once you created the folder or created the, how do I say, add Git to your project, it will create a .git directory, and it will be hidden by default, but inside it actually stored in all the information about different versions in this GitHub repository. Yeah, and also there's some errors. We're going to talk a little bit more about, say, in terms of checking out the project and essentially get a version out from the versioning database. But just what you talked about before, you can have some changes in your working directory, and then you can stage these changes. So those changes will conceptually, and it just happened conceptually. It doesn't really actually move any files on your computer, or you don't need to do this yourself. The changes will go to the staging area, then those become staged, and then you do a commit. Essentially means you save the changes in the staging area into your actual version database. Okay, yeah. This is kind of similar to what I said before. So first, you make changes of your files in your project directory, and just as you would do normally. And usually you make these changes, add new files, or add code or delete code from a file. Nothing will be tracking any changes there, and only it becomes a Git repository, is then Git will tracking the changes in these different files. And then next, this called stage changes to commit. Essentially, you select which changes you made you want to include in the next version. And so if you only has one file in your entire directory and you had made some changes, and you only had option to include that particular file. But Git is designed for much bigger projects. You can have many directories and many subdirectories. And every time, and you may want to, and maybe you have changes related to different features of the code. So maybe you only want to including all the changes related to one feature in the next version. Even there's some other changes being made, then you will stage them, mark which changes to include. And after that, you commit, which essentially save the changes to the database. So once you save a version to the database or the version database, and it's very difficult and to further change that. So it will be there, and you can go back to previous versions, saved versions at any time. But this version that you saved will most likely always be there. It is possible to actually delete, say, a version from the actual Git database, but that's not really recommended. That's not what Git meant to be, how it meant to work. Okay, and that's enough in terms of the how do I say, and the theory or the concept of how the Git works and what is version control and how the Git works. So we're going to do some more hands-on things now. So obviously, first thing is to install Git. So one thing you can do is just to check if the Git is installed or not. For example, on the Mac, I think it comes with the Git, but might not be the latest version. Actually, I don't really remember. So what do you need to do? And just open a terminal or a command window. It's called command prompt on Windows or terminals on Mac, and then type in Git version. And so if you install Git, then Git will be a command that you can use, and -- or -- version just shows the version of Git. Obviously, if you install Git, you should see something like this. And if you haven't installed Git, it will give you some error message. So I'm going to do that in my terminal now. So obviously I have, I can't move the terminal window here. Maybe this is because it's a full screen. Okay, yeah, I'll make it a bit bigger. Okay, so obviously I have installed this before. So when I type in Git version, and okay, it will shows you the version I installed. Okay, and in this case, it actually says Apple Git. So this is the one that comes with the Mac OS systems, and on your computer, it at least should show a Git some version if you have installed it. Might not have this bit. And obviously, if you haven't installed, and you should get an error message, which I can't really demonstrate here because I already installed. Let me back here. Okay, and so if there's an error, that means you haven't installed Git, and you can install it from the website. You can either just Google or just go here and then choose Mac, Windows, or Linux, and there's a file which you can download, etc., etc. And then Windows. Cancel. And usually this might be it will automatically detect which operating system you use and then give you the options to do that. Okay, and once you download it, just double click and install run the files, and then it should do everything for you. And okay, you could, if you haven't installed, I would recommend you to download and install now. It's not that big, it shouldn't take too long. And then
I'm double checking, yeah. It's about installing. It's a text editor. What does that mean?
Okay, yeah. And so during the installation of the Git, it might ask you a few questions. And one is the default text editor. So for example, when you save a new version, which is called commit, and you need to type a message, describe what changes being made in this new version. And then if you didn't include that message in the Git command, it will open up a text editor, ask you to type in the message. So the default editor is, I think, a Vim, which is not very easy to use. And you can use any text editor you have installed on your computer. So I would recommend select something you're familiar with, like say Notepad++ or Sublime Text, etc. Any text editor, you don't use the default Vim. Does that answer the question?
Yeah. So don't use the default part. Just use Notepad or anything. Yeah.
Obviously, if you're familiar with Vim, you can certainly still use it. And it's the way it works is quite different. It's a very different model of user interface. Very good. And And I think they also ask you some other questions in terms of how do you want to save the return symbols in documents, etc., etc. And just make a guess. Usually the default one is okay. Is there any other question or? Okay, and so once you finish the installation, and just try git hyphen or dash version just to see if that works. If it, then this means you are making progress. Okay, and then before you can use the Git, and you need to do some setup. These only need to do the first time, or just only do them once, and unless you later want to change these later on, but it is rare. Okay, and also these are the configurations which is affecting all the GitHub repositories. And so the way that Git work is you have one separate version database for each project you create. And in the Git terms, each project would be called a Git repository. And so you can have settings for each individual Git repositories. And what we are setting up here is for all the Git repository on your computer. So that affects every repository that we'll do. So these are called global changes. And so the command that you need is to use this one here, and git and configure, and then hyphen dash list. So git configure would do the configuration for the git, and then that hyphen list is an option to say, okay, I'm not making any particular changes. All I want to do is to see what are the current settings in my Git config file or config settings. Okay, and so you're seeing this. So this first line is specific for Mac, and what it says is stores my GitHub username password in the OS X kill chain. So that's like a Mac OS facility or feature that will save your password. On Windows will be different. Okay, but these will be useful, and it tells you the email of the user. You need one email, and this is different. For example, like from your later you create an account for GitHub on GitHub. It doesn't have to be the same email, but usually they are. And it says, and the username, so your name. And then finally, the default editor I'm using is called Nano. So that's a still command window based text editor, but it's a bit easier to use. And it's available on Mac and Linux. Maybe it's available on Windows as well, but you have to install it. I'm not sure it's come with Windows. And depends on what you choose, you might see different things here. And again, depends on your other settings. You might have this information, for example, this line here. That means you have a global ignore file. This is called git ignore. Git ignore, what it does is, what the git ignore does is, and it tells Git which files you don't want to include. And for example, there's some files generated by the system automatically, and then you don't want to include them in your GitHub repository. Then you can add them to the git ignore. And then again, you can have this global list, so which says the files will be ignored in all the Git repository on this computer. And then for each repository, you can have a different separate list of the files you don't want to include. Okay, and so if you haven't installed, or if you just installed GitHub repository, and this most likely say you would not have any of these settings yet. So what you need to do is just typing these commands to set your name and email. That's the minimum you do before you can start using GitHub. And so you just type and GitHub and configure, and this is -- global. So that means I want to change a global setting. The property I want to change is user.name. So that's the same as here. I want to set this value to John Doe, and you put whatever names you want to, or usually your name. And then similarly, this time is user.email, and which sets the emails for your Git. Okay, I think that's the two minimum. Obviously, you can set other things, and you can just look it up, say any other changes you want to set there. Okay, and then the next part is actually creating a Git repository. And so the repository is a term that Git use to describe a version database. So each repository has its own version database. So for example, you can, I think I asked you to create one repository for each of the coursework. So you have one repository for coursework 1, one repository for coursework 2, another one for coursework 3. And you can use Git for your other modules. For example, you have a Java coursework, and you can create a repository for a Java code, and then that will look after all the things related to that particular Java code. So you can have multiple ones. But you do need to create a Git repository, and before you can say start tracking or create new versions for your project or your code files. Okay, and there's a few ways to do this. And you can, I think the most common way covered in the Git tutorial you find online, you create a repository locally first. And essentially, you go to a directory and type in command called git init initialize, and then that directory, and then it's create a repository for that directory, and that directory becomes a repository. And then later, you can push it to a remote server. So here, the remote server will be the GitHub website we'll talk later on. That will be the place where you can host your database or version database online. And then you can upload all the files and your different versions to the server. Okay, so this is slightly more difficult or complicated. And because you need to get the settings right, it's how to connect the local to the remote one, and that's slightly complicated. And so what we will do, we're going to create a repository on the remote server first. So we created the online copy of the repository, which will be empty, and then copy it to your local computer. And essentially, all you need to do is do I forgot now, I've got Git clone, Git clone, which makes a copy of the repository, and then it will automatically have all the settings ready in terms of and remote repository, the URLs, the directories, and username, password, etc. Okay, I'm just looking at the chat. There's people asking for the attendance code. I'm gonna just send to everyone. And then the question say I'm logged into the wrong Git account on terminal. Do you know of a way to log out and sign into another one? And I assume when you say wrong account, so it's not these settings. Obviously, if you had the wrong username and the user email, and you can just run these command again and change to a different value, which will overwrite. For example, I can run git config global user.name Kaishu, and it will change from John Doe to Kaishu. And if it's a different one, in terms of say the GitHub account, and we can cover that later. And okay, so as I said, and so we're going to be using a website called GitHub, which allows you to host your versioning database online, and it's free to use, and it's almost all the companies or open source project use it anyway. Okay, and I mean GitHub is not the only one. There's other ones. I think people mentioned the Bitbucket or Altair or something, but GitHub is by far the most popular, and it becomes famous because actually it's providing free hosts for open source projects. But also you can still have, say, company use it as well because it's very fast and reliable, and you can have private code on there so that other people can't see. Yeah, and for this module, you have to put your code on GitHub as a repository, and that's part of the requirement. Okay, this is the largest host and for GitHub repositories, and currently it has more than 100 million Git repositories, so that's a lot. Most open source projects would have the one, as many of them say the companies would put their code on there as well for their internal development, so they are not public. Okay, and so besides hosting the code, and it also allows you to do issue tracking, code reviews, and collaboration. And so issue tracking is almost like a task list, and you can list all the different things you need to do, adding new features, fixing bugs, and they can track the progress. So that's very useful for open source development because usually there's a team of volunteers. They are not working in a company to do those. And code review is where for example, you have open source project, people want to make contributions, and usually you will not be allowed to add your changes directly to the main version of the code. So someone needs to check the changes, make sure it actually works, it doesn't have bug or did not break any existing functions, and before it can be allowed to be added to the main code. That's called code review. So you can always make changes to your own copy of the code in the repository. And then if you want that change to be included in the version that everybody else needs to see, usually it needs to go through code review and be approved. And finally, collaboration. So there's multiple people working on the same project, contributing to the same open source project. And they can collaborating through issue tracking, code review, and other ways. And so in this, so actually the code of Visual Studio Code, the code editor you are using now is actually on GitHub. So you can go there and check out the source code. GitHub, Visual Studio Code. Okay. And so you can see, and so Visual Studio Code is made by Microsoft, and this is their repository. This is actually currently including all the source code and for the Visual Studio Code. Okay, and has had over 88,000 million versions, commits or different versions of this one. And you can see who is making contributions, and it says more than 1,500 people has been made and contributions to the repository. So this is like maybe the largest or one of the examples of these larger open source project on GitHub. Obviously, there's many smaller ones, and your project there is probably not going to have as many commits or collaborators. And so, for example, the framework we cover, say, and React, Angular, or Vue, particular Vue, they're also open source, and it's also on GitHub. And I can just search here. I'm searching for Vue. Okay. This is actually searching within that particular repository. Explore. Not working. Let's say view. Okay. So now you're searching in the entire Git. As I said before, there's more than 100 billion repositories. So these ones are the which is related to Vue, and particularly it says there's more than 632,000 repository using Vue, and this is the main Vue repository. It contains the source code of the Vue and all these developers, and this is the person. Even you is actually the main developer behind the Vue framework. So if you're interested, you can have a look or even make a contribution to that, to the framework. Anyway, so the React Angular is also on GitHub, TensorFlow, and many other things. Okay. And so the GitHub is actually allows you to support team coding. As we see, this large project have over 1,000 contributors. And for the module, we're going to just focus on the individual users. So a very small team, maybe you have in your lab, you have a team of maybe 5 or 6 students, you can use the same repository, that kind of scale. Okay, and then to use that, certainly you have to first create an account, and that's quite straightforward, just as any other website. You have an email, a username, email, and password. And there's some requirements for the password, and then you click sign up. I think it will ask you to confirm, like click a link in your confirmation email. So I could sign out, and this is what it looks like. You can type in your email and click sign up. I'm not sure if you can still do it now. If I complain and say this email is already registered. Oh, they changed. Okay, it says an email. Oh, I can't really see here, and it's a bit dark. It says email is invalid or already taken, so it can't. And just depends on your. If you haven't had one, you can register, and you don't have to use your university email address. Could be any email address. Okay, and once you're logged in, and you can create a new repository, this will be empty. As we mentioned before, we're going to create a new empty repository on the GitHub first, and then make a copy, which is called a clone, locally on your computer, and use that way to connect these two. So I'm going to do that now. So depends on, so first, once you create it, I can sign in. And depends on your interface might look a little bit different from mine because you don't have any, maybe you will have no messages, activities, or repositories yet if you haven't done anything before. So there's a few ways you can create a new repository. You can click this new here. I think you can potentially use the add button here, then you can have new as well. So I'm going to just create a new repository. Then here comes a little bit information. So first you have to give the repository a name. Let's say CST3145 Git demo. Okay, and it says name is available. So basically, you cannot have the same name as a repository you created before. And then also follow certain rules of the naming, so that is okay. You can give it a description. Let's say Git lecture demo. As I say, this is optional, but usually it's good to have it there. Okay, then you choose either public or private. So public means everyone else can see, and private means only you can see. But also you need to be aware. So we will probably recommend using public, because later on you want to use GitHub Pages to kind of run your code on the GitHub website. And to do that, it has to be public so that other people can access the code in your repository. So I'll leave to as public. Okay, and then there's these things. And usually this will be good to add a Readme file. And I think the option is, once you have a file, then it allows you to clone. If you have an empty repository without any file, it might not allow you to clone. And so the git ignore file is also useful in the sense it creates a file which made a list of the file types and say, these are the ones I don't want to include in my Git. And you have templates from before, which you can use to say automatically exclude these files. For example, I don't think there's a Mac one, but it should be a view. There's no view either. And so you can see these are different languages, and people pre-made templates, which including these files automatically generated by these files. For example, Java. Oh, I'm surprised there's no view yet. Again, so this is not required. You can, but you don't have to use this. So this is Python. I'm just. Oh. Okay. So maybe I don't use any templates. That means you just create an empty file, which you can edit later on. And finally, choose a license. This is completely optional. You can choose all these different open source licenses, or you don't have to. Okay. Looks like I have to. Why is still not allowing me to create the repository? Oh, that's weird. Uncheck the git ignore. That's interesting. Okay, yeah. Thanks for the tip. And also, yeah, and even Vue.js, someone says runs on Node. You don't have to exclude any Node template here, because for now we're not using Node to manage any Vue files yet. That's weird. Okay, so now I can create. Can't use an empty git ignore file. And so that's it. So currently this is your kind of the first stage of your repository. You already had one commit. You had only this one file. It's called readme.md. MD stands for Markdown. Its content would be automatically shown on your kind of repository front page. So if you can edit these files. Okay. There's questions in the chat about using CLI for coursework. The answer is no, you can't use it for the coursework one, and we'll cover that in coursework 3 where you are using it. And the files here, actually, you can add them directly on the Git, and you either click the file and then click editing, and you can start typing other things. I'm not going to do anything now. And so this is create my GitHub repository now, create. Okay, and the next step is to make a copy of the file to your own computer. And then the interface might change a little bit now, but you need to looking for this clone or download the button. And then that's the URL you will need to clone. It usually would give you the option to either download a zip file or open in desktop. The desktop is a graphical user interface tools created by GitHub, which we will not use. We're going to use just the Git Command Line, and so we'll just need to use this. You just click this button here, which will copy the URL link. Okay, and once you do that, and you go back to your computer, open the command line window or terminal window, depends on operating system. Go to the directory where you want to put your directory, put your repository, and then type in git clone. And then this part you don't have to type. This is the part which in the previous one, where you clicked this button here, it will already be copied. So all you need to do is just paste. And then you press enter, then you should see something like this, which is actually downloading the files and from the repository. So I'm going to do that now. So I go here, I click code, and you click this one. If it's copied, that means this is the URL I need. It's already now copied to my clipboard, I think it's called. I'm not going to use any of the other options. Then I'm going to my command window. Let me see where I want to put the code. Okay, let's just do it here. Or the command you need to type is called git. So all the git commands start with git, and then the different things afterwards. So this case is clone, and which is a make it identical copy, and followed by your URL. So I git clone, and then I paste. So this is the URL I did before. Okay, and so now if you look on your computer, it should have something like this. So a subdirectory, the name will be the name of the repository. And if you go in there, and you will see inside, you only have this Readme file, which is this Readme file, which should have this information there. That's all you have for now. Let's go in there so I can show you the content. So you can see, and I'll try to display the content of Readme, and you have just these two lines, which is exactly as you would see if you click this file here. If you show raw, that's very small, the markdown file. Okay, and then afterwards we can actually add in code files to your repository, essentially the file directory, and these will be, and we're going to stage them, if you remember, to include the save in the next version, and then commit, which saves the version, and then finally upload the changes to the server. Okay, and yeah, I think we saw those lines of message somewhere here. And this is basically when it's doing the cloning of from the remote server, and it should be very quick because your repository is small, only just with one small file in it. Okay, yeah, so it just depends on the name of the repository, and if your repository is called learn-git, and it should be called learn-git here. And in our case, I said it's called Git CST3145 Git demo, so that's why it's called here. And inside you have the Readme file, and which we should check that as well. Okay, a little bit of recap. And you first need to create an account. Okay, and then you create a repository. The name is up to you, and you can use learn-git or some other names. And then you clone this on your own computer with git clone. Okay, and besides copying the files, And also now Git understands the directory on your computer is a copy of the repository on this website usually. And if you create a repository locally first, you have to set it up, and that can be a bit tricky. And so the two is now connected. Okay. And so there are many different ways to use Git. And so far, what we did is just using the command line. And so we type everything in command line. And so we type in different commands, like say git clone. And then I said git configure, all these different things. And there's also different tools which can make it a little bit easier, so you don't have to remember the command. It allows you to just select from the menus. And what we're going to cover, and we're just going to using the Git as already included in Visual Studio Code. So the Visual Studio Code is already have built-in of the support for Git, so you don't have to install anything extra. So this is what we will do, and essentially, let me see. And if you look at the sidebar in the Visual Studio Code, and in your case, the sidebar may be on the left, which you can move. And this third one, usually the third one is actually for Git. And also, say in the Visual Studio Code, if you haven't, and it has a terminal window, which is exactly the same as this window here, then you can type in all your Git commands there. It would also work. Okay. And the one thing of this is nice is because then you don't have to switch between different windows when you're writing your code. You can do everything related to Git in the same editor as well. And also the other benefit of using the terminal inside the Git is say it will always start where the directory is. So basically, if you open the folder, and then the Git terminal window would always start with the file path or directory where that folder is. So you don't have to say change there. Okay, so there's a question, say, where can I find the files after the clone? And so after you've done the clone, and the files should be a subdirectory where you run the clone command. And so what I did, for example, I run my clone inside this directory. And then after that, you can see I will have a subfolder called the CST3145 Git demo, which is the name of the Git repository, inside this folder, and that's where you find all the files. So you can see currently we have one. Okay, and if you have specific problems about using the Git command, and we can cover that in the lab because it'll be difficult to do in the lecture to do. Oh yeah, okay. So if you're just having problems using the ls command, because that's a Mac specific command, and on Windows you should type dir. Oops, it does the exact same. Obviously, that's not a command on the Mac, but then the cd will be the same, and change directory, which allows you going to a subdirectory or changing directory. Okay. Okay. Yeah. As I said before, I'm gonna mostly just using the. So what I'm gonna do now is I'm going to open this directory, or I just cloned in Visual Studio Code, and this you can run Visual Studio Code and then open the directory. Where am I now? Yeah. And what I'm going to do is I'm going to go to that directory in my terminal, and I would type code dot, which essentially means I'm going to open that directory in Visual Studio Code. The dot means current directory. So if it's recognized, and it will open this up in Visual Studio Code. And so you can see it here. So this will be the panels we're going to talking about. But first, if you click the first one, you can see this is a directory. That's the name. Or currently only has one file. If you click, it will show you and what's in the file. It says failed to install support for joining session. Okay, it's not relevant here. And then here, this third one is for Git, and we're going to mostly use all the commands from Git here. Actually, there's many other things here as well, but mostly just these things here. So this is viewed as a tree. This is the commit. We talk about a little bit. This is refresh, update, and some other commands which is hidden inside the stray dot. Now this is, you can choose what. Okay, and so once you're starting to make changes to your files, it should show up here under the changes. Currently, we just opened the directory and haven't made any changes yet, so nothing to change here. Okay, so currently we have the working directory, but we don't have any change yet. We only have one file in there, so we cannot staging or commit the changes yet, which we'll do next. Okay. So another kind of concept you need to learn, probably one of the last ones, if not the last one, and the files and in your directory, in this case, readme.md, and has two status, either tracked or untracked. And this repository is we cloned from the GitHub, and it will be tracked automatically. But if you create a new file locally, and initially it will be untracked until you add that to the stage and commit that to a new version. Okay, and then this is the one. So if you have a new file you create it locally, initially it will not be tracked. And so that basically the Git will not be aware or checking for changes of those files, and don't have these files yet. Now we actually going to start making some changes, and the changes can be, say, make changes to the existing file, or could be creating new file or even removing files, and then Git would automatically detect these, and also this will be shown in Visual Studio Code. Okay, so what happens here is actually you're starting to creating some files, and these will be detected as, say, changes in the icon and has a little stray there. That means, and you see stray files. And what these things on the side means, the first one means, and this file being modified, and these are two new files that U means untracked. So it hasn't been tracked yet. So you need to add them to staging area and commit once, and then they'll start being tracked. Okay, just because of the time, I'm not gonna make that many changes now. I'm gonna go here. I'm gonna say this is a change in the README file. Okay, that's my change here. And if I save this, you can see this Git shows there's one change now. If you click there, and you can see this file there, and you can see this M on the side, which means it recognizes this file exists before, and now it's modified. And what it can also do is gonna create a new file called index.html, and I'll put some, say, boilerplate code in there, and I save this. Okay, and you can see now here it shows it recognizes there are two files, and this is the second file. It has a U there, that means it's untracked. So that's a new file. It does not exist in the repository before. That's what the U means. So what we want to do now is to stage the changes, actually tell Git which changes I want to include in the new version. And you can stage untracked files as well, and they will become tracked. Okay, and the first thing is you don't have to include all the changes in one commit. And so in GitHub, to include the changes in the commit, you use the plus sign next to the file. Then you can individually including the changes you want. And for example, I could, oh, it's not there anymore. Ah, wrong place. So for example, I can make a change first, just including this change. So I click this plus sign, and you can see stage the changes. So that's the stage part, the middle part of the Git is this file. And you need to type in a message which describes the change. Let's say, I changed the Readme file. Okay, and then described, because that does not make much sense to including the index.html file in the same commit, because that's a different type of change. That's not about the README. Okay, and then after that, you commit your change, and all you need to do is just click this tick button here. So just this button here, and if you wait a little bit, it will tell you that means commit. Okay, once you click the commit, the changes are stored in your local Git repository. It's not on GitHub yet, so this will not be there. And this is what the next step we'll do later. Okay, and once you save, that becomes a new version in your history. Also need to type a message describing what the change is, which I did here. And then now I'm gonna just click the button, and what happens now, the stage the changes disappeared, and because now it's saved, it's no longer staged, it's already saved into the Git database, and the only change that's remaining is this one. Okay, and so if you want to upload the changes or sync your local with the remote version database, which is on GitHub, I use something called a push. But what I will do now is I'm gonna commit my next change as well. So I'm gonna just plus. Then I can see this one is in the staged area. And then typing the message, I say the created an empty HTML file. And then I click commit. Okay. So now there's no more changes because all the changes are now saved locally. So what I can do now is I can upload these changes to my remote repository. So these two version databases are in sync. So what you do is go click the three dots and then choose push. Then those changes will go to your GitHub repository. Okay, and so just have a look of the GitHub repository again. I don't want to create another one. I already did. Let's see. Yeah. Okay, this was the repository we had before. We can see it only has one commit and only this one file, which is shown up here. And now if we go back to here, and I choose 3 dots, and I choose push. Sorry, the text a bit small. That part is not affected by the function. What it will upload the changes to the server or the GitHub website, and it will including the 2 commits I made before, not just one, both of them. So I click push, and it has a little bit of line. It shows, okay, so now it's probably done already. And if I go to my GitHub repository and I click refresh the page, yeah, and you can see that say now you have made 3 commits. And if you click that, and you can see there's one commit made 3 minutes ago, and you can see the message say I changed the Readme file, and the other one says done 2 minutes ago, say created empty HTML file. Okay, and then for the group coursework, and you need to just make 5 commits. You can see it's very easy. Just for in a few minutes, I already had 3 commits, so there shouldn't be any problem at all to have 5 or even 10. Yeah, and so this is what you will see, and you can see the comments, and which I just showed you by click on the number of commits, the 3 commits number here. You can see the history in more detail. Okay, so the opposite of the push, which is upload changes to the server, is pull. So pull is say, for example, you're working with a team, other people made changes, and they put their changes onto the GitHub, and you want to get those changes. So you want to get changes from the server to your local copy of the version database. That's when you use pull. And so this could be also, you have 2 computers, and one of them, it has older version of the code, and you want to get the latest version, you can be also using pull. And you don't use pull for the first time. First time, if they don't have a repository yet on your computer, you use clone. And once you have a repository and you just want to get the latest changes, and you use pull. Okay, I'm not gonna demonstrate this. Potentially I can. Let me just check the time. Yeah, maybe it's possible. And for example, I can make a changes on the GitHub repository itself, and it almost like make a commit as well. As I said, you can edit these files here. So in this case, I'm gonna just click edit the file button. And then I'm gonna say, I made some changes and using GitHub Online edit. Okay, and you can do something like this, and then you can commit the changes. This is the same. And you can set the message, and you can commit the change. So this way, you can also create a new version for your project. And if you go back, you can see the files now. You can see this new line I just added. But if you go back to the GitHub repository, you can see there are now 4 commits. And these 3 are done earlier. Actually, 2 more are done on my locally. And this is one I did. Just using the online interface in the GitHub repository. So now, and if I go back to my local code, and obviously in my README here, it hasn't changed yet. It does not have the changes I made. So if you want to get that latest changes, you go here and you go again 3 dot, and that's the first one. I'll just do a pull. Okay, and you can see now the readme.md file as it is already updated, and including this new line I added online. Excuse me. So this is how you use pull. Okay, yeah, and so the general principle or the way to use commit is commit often, and don't make a lot of changes, like writing hundreds of lines before you make a change. Usually, when you made some progress and do a commit, a new file finished, and add a new title, finish some functions, do a commit. There's no penalties of having too many commits, not really. But the more commits you have, and the fine-grained control you have in terms of different versions you need. And Git allows you to go back to any previous Git commits or the version of your code. Okay, then now you can never lose your code. For example, you should never say, oh, my computer crashed, so I lost all the work I did 2 hours ago. In these 2 hours, you should have made several commits and pushed them to the GitHub already. So you should only lose the work between what you did now and the last commit. That's why another reason to commit often and push them to the server, so you can never lose your code again. Okay, for the individual work, I'm asking you to have 10 commits. Again, you see, so it's very easy. I already have 4 or 5 on my GitHub now, so 10 is really not difficult at all. Okay, and the last bit I'm going to show you using GitHub Pages, which allows you to run the code online, and it can only run front-end code. It can't do back-end code. So for example, it can't host a database on GitHub. Essentially, it can run the code which in your GitHub repository. And so in this case, for example, it will be able to run the HTML file, even if it's just currently is empty. And so it's actually very simple. It's just a setting issues. So if you go to settings and you scroll down, you should have a section called GitHub Pages. So if it's not public, and you have to make the website public first, because the people to see your code online should have access to the code file, and they can only do that if the repository is public. So you have to make the repository public. And if you have done so, you can change that in the setting as well. Okay, and then you need to select the branches. Okay, let's just go back a little bit. So go to your repository, go to the settings, and if you just the first one on the left, and if you scroll down, okay, it has wikis. There's many options. Okay. So it used to be here, but it now says it has its own tabs on the left. And so there should be, I assume that means there's something on the left here is for GitHub. Not here. Pages. Okay, it's just called pages here. So I assume now if you click this, you should go to here. And this is what looks like if your repository is already public. If it's not, it looks different. So if we go back, you need to change the visibility to public. So currently it's public, you can change to private, then it doesn't allow you. And if you're private, you can change it to public here. It asks you to type in this again in the text box just to confirm. Okay, and so if you already changed it to public, it should like this. And what then you need to do is you need to tell GitHub what code you want people to be able to see. And so this is actually usually stored in different branches. And so you can see the different branches options here. And so by default, there's only one branch, it's called main, and you can create multiple branches. These are like different versions of the same code. And again, we're not going to come into the details here, but you have to tell, you can have multiple ones. So you have to tell Git which one to use. By default, it's none. So that means it's not going to be able to see anything. So I'm going to choose main and root and then save. And that's it. Then you can have a link here, and which actually tells you and how to access the web page or the code online. So I can just open that one in a new tab. Well, it says not found. Yeah, just the root, custom domain. This is a bit odd. Okay, so maybe I have to type in the file name. It should work. That's interesting. So 145 Git demo. Okay, now it works. So my apologies, saying the text is very small, and essentially I just click the link. So it maybe take a little bit of time for it to go online. So maybe that's why initially it didn't. And so if I click just that link now, there's no more error message. But it's an empty page. That's just because for the HTML page itself, I haven't had anything yet. And so if you view page source, you can see the source code, which is exactly what I did before. And you can also just type in, say, and readme.md, that's the other file. It doesn't show it either. Okay, and so let me go back to the lecture slides. Yeah, yeah, you select the branch and you would have the URL. Yeah, and that's the reading. Okay, so this is a separate book you should use called the Git Book, and it's written by the people who made Git. So it's the official guide, and you only really need to use the first two chapters. The first one is just a very brief and introductory, and the second one covers everything we already mentioned today. You don't actually much more than that. You don't even need to complete the second chapter. And so for now, if I really want, and I can make some changes to my file here, like the index. I might add a as a body h1, say git demo, and then I can commit the changes and then push it to the server. Then if I go back to my code, I have 5 commits now. Or you can just check the code. You can see the HTML page. Now I have the h1 in there. Now if I refresh this page, oops, it's still not there yet. Wrong file. Okay, you can see now, and it now have H1 heading with the changes I just did. Okay, and so this will be roughly the workflow you will do from now on, is to make changes locally, test it's working, and you can push it onto the server, and then you can see it on the GitHub pages. Okay, I think that's all for today. I'm gonna stop there. Just end of our session now.